Alright, so this, I just want to show you kind of a picture of what that graph looked like in the last case before we do a couple more examples. This software, this is called Desmos. It's a nice graphing calculator site, and sometimes it gives you a better picture than a standard TI-80 type of calculator. If you look at this graph we have over there in red, this is the equation right here that we have. The other two are ones we're about to do in just a sec. That's what the graph looks like. If I turn on this line x equals -4, that orange line that just showed up, you can see that that's the asymptote. It gets really close but never actually touches. And this is what you can do when you're graphing these. You can always come to this site and test out and see, plug in the graph and see does yours look like what they got. And then we said that there should be a hole at -2, -1. So if you zoom in here, it looks like, we're going to have to zoom way in. So this is the point -2, -1. It looks like it's filled in. You can't really see it. You have to zoom all the way in here. Sometimes you have to play with these, but here's an easier way to do this. If you zoom all the way in, okay, I'm clicking on that red line. You can see they're giving us coordinates. They're giving us coordinates, getting closer and closer to -2. And then when I finally get there, you can see it just flash, but -2 comma undefined. So you can see right there, there's a hole in the graph because at -2 you cancel the top and the bottom. So there was an asymptote at -4, but a hole at -2. I just wanted to show you the visual on that so you can see kind of how it looks. And obviously you have to zoom in, you can't really see it otherwise. Okay, but this is a good way to check our graph. So let's take a look at these other two cases now, case 2 and case 3. So case 1, the one that we just did, okay, you had an example of the denominator and the bottom being larger than the degree of the denominator, I should say, being larger. X squared in that denominator is larger than the top, which is x to the first. So that's case 1, and in case 1, the horizontal asymptote is this line right here. It's y was equal to 0. Okay, so that line right there. So let's just kind of keep a summary for ourselves here. Case 1, that's when the denominator degree is larger than the numerator degree, and in that case the horizontal asymptote will always be the line y equals 0. Now we're about to do case 2. Case 2 is when the degree of the denominator is smaller than the degree of the numerator. So you can see right here the largest degree down there is x to the first. The largest one up here is x squared. And what will happen in this case is that you actually won't get a horizontal asymptote. You'll get what's called an oblique asymptote, like a slanted line in many cases. It doesn't have to be a slanted line, but the ones that we'll consider will be. Okay, here's why that happens. So let's take this equation, and remember these asymptotes occur as x goes to infinity, as the graph gets really large either in the positive or negative direction. So let's plug in infinities for all those x's that we see in this equation right here. So I'm going to plug in infinity squared plus 3 times infinity minus 4. Okay, so infinity squared plus 3 infinity minus 4 over 4 infinity plus 4. So again, what's going to dominate here? Everything that has infinity, the largest infinities are going to dominate. So these numbers don't even matter. We're out infinity. And up here, infinity squared is going to be way bigger than 3 infinity. So the top is going to be infinity squared. The bottom, again, we don't care about any of this stuff except for the 4 infinity. So if this were like x squared over 4x, that would cancel becoming an x, and that would cancel completely. You'd just be left with x over 4. So in a similar way, the infinity up here will cancel and here will cancel. We're left with infinity over 4. Infinity over 4, infinity over everything, basically equals infinity. That means the asymptote is not going to level out like it did here. It's not going to be y equals 0. It's going to shoot off to a massively large number. And again, this might be a little abstract because we haven't seen the picture yet. And when you see the picture, I think it'll make more sense to you. So let's do our same 4 steps. These are always the 4 steps we use in graphing. Our first step, let me just add this case 2 here. Case 2 is when the denominator degree is smaller, and in that case there is no horizontal asymptote. You get a slant asymptote, and we're going to find that using long division, which we've done before. Okay, what's our first step? Our first step is always to factor. So the top can be factored. If you look at that, ask yourself, and try to skip ahead. If you want to pause and give this a try, I recommend doing that because it's the same procedure we did in the last video. So we're looking for numbers that multiply to -4 and add to +3, and the numbers that do that are +4 and -1. Okay, the bottom doesn't factor like the top. It does have a common factor though. It has a common factor of 4. So if I pull out a 4, I have x plus 1. Okay, so we're done with factoring. Let's find the x-intercepts right now. Okay, the x-intercepts occur when y equals 0. So we're going to take our equation right here and we will set it equal to 0. Okay, the only way that this can be 0, there's actually two ways. Okay, the two ways that this equation can be 0, if that one equals 0 or if that one equals 0. So I'm going to set x plus 4 equal to 0. I'm also going to set x minus 1 equals 0. This one gives us negative 4, so that's going to be an x-intercept. So I'm going to put a point at negative 4. This one, when we solve it, is going to be x equals 1. So there's another x-intercept that I'm going to put right there. Okay, the question you might have is, first of all, why can't we cancel anything? And that's because this is x minus 1 and that's x plus 1. They have to be the same to cancel. So we're not able to cancel anything. Second question you might have, why is there not a hole in this graph like there was in the other one? And the answer is because there's nothing that we can cancel. Okay, there's no way, we don't want to make this bottom equal to 0 because that's not going to be an intercept. That would be either a hole or an asymptote. It's not going to be a hole because we're not able to cancel like we did on the last problem. Okay, so we found the x-intercepts. Let's now find the y-intercepts, and those will occur when x equals 0. Okay, so the y-intercepts will occur when x equals 0. So let's plug into this equation 0 wherever we see an x. And when we do that, we'll have this. The top will come out to be 4 times negative 1, which is negative 4. The bottom will be positive 4. So negative 1 would be the y-intercept. So I'm going to put a point at negative 1 right there. So we're done with factoring. We're done with intercepts. We said there are no holes. Okay, let me give you an example of when there would be a hole. Suppose we had this same exact equation, but instead of the bottom being 4 times x plus 1, it was 4 times x minus 1. If that were the equation, these would cancel, and you would have a hole at whatever makes these 0. And x equals 1 would make that 0. That would be an example of when you'd have a hole. But that's not going to be the case here because, in fact, we are not able to cancel the top and the bottom. They're different values, so that's not going to work. So I'm just going to erase this. Okay, so no holes. We will have asymptotes, though. We will have vertical and horizontal asymptotes. Let's start with the vertical asymptotes. Okay, so the vertical asymptotes are going to be, vertical asymptotes always occur at what makes the denominator equal to 0. So if we look at this equation again, what is it that's going to make the denominator, meaning the 4 times x plus 1, what's going to make this equal 0? And the answer is negative 1. If you plug in negative 1 right there, you'll get a 0. That's where vertical asymptotes occur. So I'm going to draw a vertical asymptote right here at negative 1. Okay, again, just to point something out, there's only one vertical asymptote, so that means there will be two regions on our graph. One region to the left of the asymptote, one region to the right. If there were 3 vertical asymptotes, we'd have 4 regions. If there were 4 vertical asymptotes, we'd have 5 regions. Okay, so we're done with the vertical asymptote. We got that. We set up here, because this is a case 2, there's no horizontal asymptote. There will be a slant asymptote, though. How do we find that? And the answer is we use a concept that we've done in the past called polynomial long division. So here's how we would do that. Let's take this equation that we have and we will just do 4x plus 4 and see how many times does that go into the top right here. Okay, so 4x plus 4, that's another way of saying we want to see how many times does 4x go into x squared. We're really only focused on that right there. Okay, so this is a 1, by the way, a 1x squared. So 1 over 4 stays the same, and x cancels, and one of those x squareds cancel. So we're left with 1/4 x. So I'm just going to write that on the top of the division bar right there. Okay, so we have a 1/4 x right here. Now what do we do from there? 1/4 x times 4x would be x squared. 1/4 x times 4 would just be x. So we're doing long division. Now we're going to subtract these. Those will go away. 3x minus x is 2x. We bring down the minus 4. How many times does 4x go into 2x? That's another way of saying what is this equal? 2x divided by 4x. The x's cancel, and 2 over 4 is equal to 1/2. So I'm going to put a 1/2 right there. What's 1/2 times 4x? That's 2x. And what's 1/2 times 4? That's 2. So when we subtract, those go away, and negative 4 minus 2 is negative 6, and that's our remainder. Okay, so what we just have right there, this equation, that's actually going to be the asymptote. It's not a horizontal line. It's going to be like an mx plus b, a slope-intercept type of line. Okay, so I'm going to do that a lot of purple here. I'm going to change this. We'll do this asymptote in red. Here's the other thing. You might ask yourself, how am I supposed to graph this? This looks pretty complicated right here. Really, all that you have to graph, and I'm going to write this, by the way, the name for this asymptote, it's called an oblique asymptote. The only thing that you have to graph here is you have to graph y equals 1/4 x plus 1/2. You don't need to pay attention to this remainder, and here's why. We said that the asymptotes occur, the horizontal asymptote occurs as x is going out to infinity. But if you put an infinity in the bottom of that fraction, I know it's getting messy, but if you put a infinity right here, where there's an x, you'd have -6 over a massively large number, over basically infinity. Anything over something close to infinity is going to get really close to 0. Okay, so this this right here is just going to approach 0. So that's why we don't even care about that other part, the remainder of that long division. So I'm going to graph the line y equals 1/4 x plus 1/2. The y-intercept is 1/2, so 1/2 is about right there. And then we're going to go up 1 over 4. Okay, then up 1 and over 4 again, and that's pretty close. And we'll make a dotted line to indicate that this is an oblique asymptote or a slant asymptote. And let's go the other way. Let's go down 1 over 4 just to make this somewhat accurate. Down 1 over 4. There's our oblique asymptote. So that means it's going to, the equation goes out towards infinity, it can cross that asymptote somewhere in the middle here, but as it goes out forever in this direction or forever this direction, it's not going to cross that asymptote. All right, so where are we on our steps? And these, obviously, these take a little bit of time when you're first practicing, but we're on our way. We're making progress. We've got factors, we have intercepts, we have vertical and horizontal, or I should say oblique asymptotes. Last thing is to draw the graph. How do you draw the graph? Well, we pretty much have it right now. Okay, if we were to graph as is, so these 2 points right here, we know those will connect. We know that this right here is going to have to get close to that asymptote. There's no other way that we could draw the graph so that it would cut close to that asymptote. And then same thing down here. We know this has to go down. It's not going to suddenly swing upwards. The only way it could go is down to get close to that vertical asymptote. So there's our picture right there. And then over here, we benefit from having one more point in the other region of the graph, because we know that it's going to get close to this asymptote right here, so we could draw it this way, but we don't necessarily know what it's going to do over here. It's probably going to have to go up, but just to be a little bit more accurate, let's make a quick table right here. So y equals this equation, and here's what we have, and then let's take a number. That's this x point right here is at -4. Let's just plug in -3 to see what happens. So if we plug in -3, the bottom will be -12 plus 4 is -8. If I plug in -3 right here, that's going to be 9 minus 9 minus 4 is -4. So that equals 1/2. So that means the point -3, 1/2. So then we can just connect that, and we know it's going to get close to that asymptote. Okay, so that's what it looks like. You can see it. There is an asymptote. It's not a horizontal asymptote, though. It's that red dotted line right there. All right, let's do one more. So we've talked about case 1. The denominator has a bigger degree. Case 2, the denominator has a smaller degree. That leaves us with case 3, when the degrees are equal. Okay, and what happens in this case is the asymptote, there will be a horizontal asymptote. It's going to be the ratio of the leading coefficients. So here's what that means. Here's our equation, and again, I'm going to remember these asymptotes occur, horizontal asymptotes occur as x goes to infinity. So I'm going to plug in infinities wherever there are x's. Okay, so that's going to be infinity cubed. We're using obviously this f of x right here, and then over here we're going to have 3 infinity cubed minus 6 infinity squared minus 9 infinity. Okay, what's going to dominate here is going to be infinity cubed. That's way bigger than this. And 3 infinity cubed is way bigger than this. So all we care about is infinity cubed over 3 infinity cubed, because infinity to the 3rd power is way bigger than any other infinity that you see there. Suppose that those were x's. How would you do that? You'd cancel this and make it a 1. You'd cancel that and make it a 3. You'd be left with 1 over 3. It's the same thing here. I'm going to cancel infinity cubed. I'm going to cancel infinity cubed. And so I'm left with 1/3. That is our horizontal asymptote. So that's how you would do an example of case 3. You basically look at the leading powers. The leading powers here are 1x to the 3rd and 3x to the 3rd, and this number over this number is our horizontal asymptote. That is case 3. So just to recap, case 1 would be something like this. It would be, let's say, 4x over 3x squared. In this case, the asymptote is going to be equal, sorry, that should be just a period there, is going to be y equals 0. You're going to have infinity over infinity squared. Infinity squared is way bigger. That wins out. So that number starts to approach 0. Case 2 is something like 4x squared over 3x. So this time the numerator has a larger degree. This has no horizontal asymptote. It has an oblique asymptote, and you have to find it using long division like we did before. Case 3 is when they're equal, so like 4x squared over 3x squared. In this case, the asymptote would be the ratio of that to that. So 4 over 3 would be our asymptote. So those are the only 3 cases that you'll really see. Case 1, case 2, case 3. This is a case 3. And we're going a little bit out of order on these steps. We just found that the horizontal asymptote is this, so let's graph it. So 1/3 is roughly right about there, not perfectly drawn to scale, but close enough. And let's see, I'm trying to do the best I can with this dot right here, but it's not turning out quite like I had hoped. Hopefully that's clear enough. Okay, now again we need to factor, so let's clear off some space for ourselves here. So this, I'll just label this. This is our horizontal asymptote, y equals 1/3. HA stands for horizontal asymptote. Let's factor this. So the top has a common factor of x squared, and when we pull out an x squared, we're left with x plus 4. The bottom has a common factor of 3x, not just x, but 3x goes into all of those. When you pull out a 3x from 3x cubed, you're left with x squared. When you pull out a 3x from 6x squared, you're left with 2x. And then finally, negative 9x divided by 3x is minus 3. And then we can even factor this more. Okay, so the top is going to stay the same. The bottom, 3x is still there. The bottom is going to factor to what multiplies to negative 3 and adds to negative 2. That would be x minus 3 times x plus 1. So this is our factored version. We've now factored right there. We found the horizontal asymptotes. Let's find the intercepts right now, because that's usually our next step. So the x-intercepts will occur when y equals 0. So I'm going to set that equation equal to 0 right there. And it looks like there are 2 ways that that could happen. There's 2 ways that this could equal 0. One way this could equal 0 is if x equals negative 4, because that would make that parenthesis 0. The other way is right here, if x were equal to 0. That would make x squared 0. So negative 4 is going to be an x-intercept, and 0 will also be an x-intercept. So those 2 points that you see right there would be our intercepts. Okay, how about the y-intercepts? I'm just going to kind of move this out of the box out of the way so that we have more space. So we'll move it up here. I know that it's kind of overlapping there, but we need the space. So y-intercepts here are going to occur when x equals 0. Okay, so all we're going to do is take our equation that we originally had and plug in 0 for all the x's. And sorry, that's supposed to be a 0 there. We'll see what happens when we do this. So the top, 0 times 0 plus 4 is just going to be 0. And the bottom, it doesn't really matter because 0 on the top is going to seal the deal for us. But the bottom is also going to be 0. Okay, now that's a problem. 0 divided by 0, we can't do that. It doesn't work. Okay, you can't divide by 0 no matter what. So that means there are not going to be any y-intercepts. Okay, in terms of holes, will there be any holes? No, there won't be, because we can't cancel that x plus 4 there. If one of these on the bottom were x plus 4, there would be a hole at negative 4. In this case, there are none. Okay, vertical asymptotes. There will be vertical asymptotes. Okay, the vertical asymptotes occur when the denominator equals 0. So there's 3 ways that could happen. X could be 0 right there. Okay, actually, sorry, I misspoke when I said there is no hole. There will be a hole. We'll come back to that in just a sec. X equals 3 is going to be a vertical asymptote right there. X equals negative 1 will be a vertical asymptote. And I don't mean to confuse you. I said there was going to be no hole. There actually will be. It's just a little bit harder to notice. Okay, notice that I was about to say x equals 0 would be an asymptote, but it won't be, and here's why. You could cancel this x right here with that x squared right there. So that means because we were able to cancel, that right there is going to be a hole on the graph. So I should not have filled in this x equals 0 right here. That's actually not going to be there. There's going to be a hole right there. Okay, now how do we find out what the hole, where the hole is going to be? We need to plug in 0 to our reduced equation. Okay, so our reduced equation means that this one right here, we've canceled the x's. If we plug in 0, well, actually it still will be. So 0 times, that's going to be 0 plus 4. 0 times 4 is 0, and the bottom, it doesn't matter what it is. So there actually will be a hole right there at 0, 0. Okay, I don't want to confuse you. The reason there's a hole is because, remember, we said holes occur when there's something on the top and the bottom that cancels. And what is it that we canceled right here? We canceled an x. So whatever makes x equal to 0, and the only way you can make x equal to 0 is if it equals 0. So that's why there's a hole right there. Okay, there are vertical asymptotes that we said at 3 and negative 1, so let's put those in there. So here's negative 1 right here, and then we'll have 3 next to it. And then from there, we just do our regular steps like before. Our last step is draw the graph by getting some points. Notice there are 2 vertical asymptotes. So that means we're going to have 3 kind of sections to this graph. 1 to the left, 1 in the middle, and then 1 to the right. All right, so let's get some points right here. So let's get a couple points to the left. So we have a point at negative 4. Let's get a point at negative 3 just to see what that looks like. And that's really all we need because we know that right here it's going to get close to that asymptote. So we don't really need any points over there. So negative 3, this is our equation here. I'm just going to rewrite it so we have it. So if we plug in negative 3 right here, the top is going to be negative 27. What is that going to be? 9 times 4, so 36. So negative 27 plus 36, just doing some mental math here. And the bottom is going to be negative 81 plus 27 will be negative 54, and then minus 54. Negative 54 minus 54. Okay, so I believe this is going to be, what's that, 9 over 108, which reduces to 1/12. I just want to double check to see if that is correct. Let's see, let's do one more just to double check. So negative 3 1/12 would put us roughly right about there. Let's get one more point. So negative 2, if we plug that in, we'd have negative 8 plus 16, which is 8. And the bottom would be also negative 24 plus 18 would be negative 6. Negative 6 minus 24 would be negative 30. So 8 over negative 30 would be negative 4/15. And yes, that seems about right too. So that would put us at negative 2. So this part right here is going to go up like this. And you might say, well, I thought you can't cross the horizontal asymptote, and we just crossed it right here. You can cross it, you just can't cross it as x goes this way or this way as you go out towards infinity. So it's fine to cross it somewhere in the middle. So that's our first region, that purple line right there. Let's get the middle region. So we already have a hole in the middle region at 0. So let's plug in a point to the left of 0 and a point to the right of 0. Okay, and we'll do the middle part of the graph in different colors. So this one will be in green right here so we can see it stand out a little. So there's our hole. We want a point to the left of that. So let's do negative 1 and a point to the right to that. Let's do positive 2 because positive 2 is a little bit closer to the other asymptote. So if we plug in negative 1 to our function right here, we have negative 1 cubed plus 4 times negative 1 squared would be 4. Okay, and then the bottom is going to be, what's the bottom going to be? Negative 3. So let's get a little bit more space here. You can see obviously these problems do tend to get pretty involved with the work, so I just want to give us some more space. So the top again was negative 1 plus 4. The bottom is going to be negative 3, and then it's going to be minus 6, and then plus 9. When we add these together, it's going to end up being 3 over, is that right? 3 over 0. I think we should say I made a mistake somewhere in the mental math. So what is it? Negative 3 plus 10 is 7. Okay, so sorry, the bottom should actually be, it looks like 1. Let me just double check that. Negative 3 plus 9 is 6. No, 6 minus 6. That is 0. So I'm wondering, let's see what happened there. Oh, you know what? -1. I'm sorry. I don't know why I'm plugging in -1. -1 is the asymptote. That's why it's not working. Okay, so let's switch. We need what I'm trying to do here is plug in a point to the left of this just so we can see where the graph goes. Shouldn't plug in -1 though because that's our asymptote. So let's plug in something like -half. -half would be better. So let's do -0.5. Okay, we'll plug in -0.5 to this equation right here. So -0.5 cubed is going to be, this one's a little bit tricky to do without the calculator, but we can do it. So -0.5 cubed, and then we have 4 times 0.5 squared, and then the bottom is going to be, the bottom will be a little bit easier to use the factored version. So our factored version is over here. So 3 times 0.5, then we have 0.5 minus 3, and then we have 0.5 plus 1. Okay, so the bottom is going to be, what is that? -2.5 times 1.5, and then times 1.5 again. Okay, so that's going to be roughly -2.5 times 2.25. Let's see what that ends up equaling. -2.25 times 2.25, and that ends up equaling about -5.6 roughly. Okay, so this is roughly -5.6, and the top is going to be -0.5 cubed. So -0.5 cubed is -0.125, and then plus, looks like plus 1. So that's going to be 0.875. So our, just obviously if you have questions like this, you can certainly use a calculator, but this will roughly simplify out to be like -0.15 or -1.16, I should say. Let's clear this off for a sec. And so that means we're going to have, all we're doing here is just trying to see where this graph is going to go. So this whole thing roughly simplifies out to that. You can use a calculator for this. So -0.5, -0.16 is right here. That means we're below the 0, so we're going to go down that direction. And then let's plug in 2, which is a little bit easier to plug in. So if we plug in 2 to this equation up here, we'd have 2 to the third, which is 8. 8 plus the other one will be 16, so that's 24. The bottom is going to be 24 minus 18 is 6, and then 6 minus 24 is -18. So this is roughly negative, not roughly, I should say -1 1/3. Okay, which puts us, where is that going to put us? About right here. Okay, so we can see that that graph is going to go down in this direction. The only thing we need to know is it going to go up or down, and that's what it told us. Okay, the last part of the graph, that's that third region. We'll do this one in different colors, so blue. Just need 2 points right here. Let's use 4 and 5. Keep it simple. So 4 and 5, when you plug them in, you're going to have this one, the top will be 4 cubed 64, plus 64 is 128. Okay, the bottom is going to be 192 minus 36 is 156, and 156 minus 96 is 60. Don't worry about where these numbers are coming from. You can use a calculator. All I'm doing is taking 4 and plugging them in for x right there. Okay, so that is roughly 2, and maybe it's about 2.2, 2.3. Not so important what the decimals are, so roughly about that point. And then all we need to know is it going to go up or down from there. So if we go from plug in 5, 5 being plugged in, what's that going to be? 125 plus 100 is 225, and the bottom is going to be 375 minus 150 is 225. 225 minus 45 is 180. So this is roughly, that's about 1.25. Okay, so that tells us what we needed to know. It tells us that we're going to go down like that, and we have to go up like that. So this right here is the graph. Quite a few steps, and it does take some getting used to, but the idea is that when you're graphing, you need to factor, find the intercepts, find the asymptotes, and then if you don't have a clear picture at that point, you can draw the graph by making a table of values. So hopefully that makes sense. It does take some practice, but if you follow those 4 steps, you should be good.